Hello everyone, my name is Mark. Welcome to my Calc 3 videos. And today we're going to talk about functions of Serval variables. This is the first video for chapter 15. And the first question I have for you is domain, right? So when a function is made of several simple functions, right? How can we find this function's domain, right? So I give you several examples, right? So the way I think about finding a function's domain is I apply a top-down approach, okay? A top-down approach. I look at the most prominent feature in the function, right? Let's say, for example, right, the cosine of x or y, right? Oh, sorry, let me just use this example, right? A natural log example, right? The most prominent feature of this function is its natural log, right? So that means whatever is inside this natural log has to be greater than 0. And then I can start thinking about the lower level, right, which is what's making up this parenthesis, right, x plus z, right? Now I need to think about, well, because the natural log needs to be greater than 0, so that means my x plus z also needs to be greater than 0. And that gives me consideration of what the value of x and z should be. I hope that makes sense. So, and we'll use some example to illustrate that. The second question is, well, what are the difference between traces, level curves, and contour plot? So, traces is explicitly referred to as x, y trace, y, z trace, and x, z traces. That means the missing variable equals to 0, okay? I think this is kind of like a review for you. Right, so x, y trace, z equals to 0, y, z trace, x equals to 0, right? And level curves is different. Level curves mostly refer to the x on the traces on the xy plane. So okay, but instead of z equals to 0, z equals to k. It's an arbitrary constant, and you can set this k to whatever value you want, and then with different k values, usually we'll get different shapes of curves. And then contour plot is a combination or collection of level curves. Right? Usually the difference between the k values are the constant, right? Usually delta k is constant. So let me go ahead and show you some examples of the contour plot. I'm a pilot, so I like to use some weather examples. So let's go ahead and hit done. And then, so this is an app called Windy, not the windiest restaurant, but this is a really cool app that I actually use to illustrate this concept. So we are currently looking at the pressure map of the continental United States. So you can see that we have a high pressure zone labeled at 1039. That's kind of your z value, right? Your k value. And then if we look south, right, we can see that the value drops down a little bit, right? We're kind of like descending from high pressure to low pressure. So we have 1036, and then 1034, 1032, and 1030, right? So these values are pretty much very constant to each other. So and then we can, let me take a screenshot of this, right? If we follow this 1024, never mind. Let's say if we follow this 1022 curve, and then we can follow all the way to Indiana, right? So that's probably where West Lafayette is. And this is the pressure of the West Lafayette region or Indiana region in general. So along this line, the pressure is 1024. I'm not sure what the unit is, but it's whatever the unit that is representing, right? So I hope that makes sense a little bit to you. And then we can go ahead and switch to temperatures. And then we can, I don't know where I can change the pressure on the isoline settings. More layers. And then I'm pretty sure I can scroll down to display isolines, right? We can select to temperature, right? So these are the temperature of United States. This is a temperature map in United States, and the isolines representing the temperature. So I'm pretty sure it's in Celsius, as you can see at the bottom left corner. So Indiana is about, let's say, like West Lafayette is about like 1 degree, 3 degrees, somewhere along the line, right? So I hope that these two examples make sense to you. So, right, so demo, we just showed you about that. And then let's go ahead and look into some example questions. So let me go ahead and open my one-pagers and then the solution sheet that will be working together. So, right, it's asking for you the domain of the function, right, the natural log of x over y plus 2. So I think, again, this is an easy way to tell what type of question it's asking, right? So this is the domain of the function, right? Domain of the function. So this is a function domain problem, right? And the keyword is just the domain. So the first step to solve this type of question is what I would call is break down the function into its components, right? So, right, for example, it's function that's inside a function, right? Let's say there's some multiplication, division inside the function, and also there's some addition and subtraction, and also some sort of a power, log, or maybe even square root if you need it, right? So in our case, our function is f of xy equals to natural log of x over y plus 2, right? So to break this function apart, right, so again, it's a top-down approach. So we're going to start with natural log of y, so natural log of something, right? And then we're also going to have x plus y over plus 2. And then this is the fraction, so we're going to have x. We're also going to have y plus 2. So, so that's the first step. Break down the function into components. And then the second step is, I would say, it's find the domains which the component is valid. And then we're going to take a top-down approach to examine this function. So natural log, that tells us, right, so whatever is inside here has to be greater than 0. And then this is a fraction, so this tells us whatever is the fraction, it has to be greater than 0 as well, because this fraction, remember, it's inside this natural log. So now let's examine the x and y plus 2. So because these two lies inside the fraction, and fraction has to be greater than 0, so that means it's either x greater than 0 and y plus 2 greater than 0, right? So that means y has to be greater than negative 2. And then alternative, right? So this is sort of a combination of the analyses. So we can also have set x is smaller than 0 and y plus 2 has to be smaller than 0 as well. So this tells us y has to be smaller than negative 2. So now we have complete analyses. The final step is just combine the domain of each variable, right? So we don't really worry about whatever is in here, right? Whatever is in here. So that's the first step, second step, and then the third step, right? So we are only focusing on the the variables themselves. So we have the first case is x greater than 0 and y greater than -2, x smaller than 0 and y smaller than -2. Easy enough, right? So this is, and we're going to, and this is the answer to this question, right? X greater than 0 and y greater than -2, or x smaller than 0 and y smaller than -2. So that is answer choice B. Right, so this I think is this is kind of a easy question on the exam, right? And I think this is just kind of taking one step further from what we have already known in Calc 1 and Calc 2, or even pre-Calc, right? So that's a pretty easy question to solve. And then let me switch the notes orientation back. And let's go ahead and take a look at a different type of problem. Right, so now we're talking about level curves, right? So again, this is the easy question to identify, right? This is a level curve, right? And you also have this function of f of x, y equals to something, something, right? So to solve this type of problem, first thing we're going to do is to set f of x, y equals to z, which equals to k, right? So f of x, y, right, you can think of this as just z of x, y, right? Z of x, y as well. So first step is k equals to, the function itself, x squared plus 1 minus 2y. So that's first step, easy enough. And the second step is we're going to turn the expression of the function into a conic equation standard form. The key is that we're going to turn it into a standard form, okay? And then if you go back to our quadratic surfaces video, I already showed you what those standard forms look like. And then to get there, this usually requires some sort of rearrangement and removing the square roots. Okay, square roots. So in our case, step 2 is going to be, let's go ahead and remove the 2y to the left hand side, plus 2y equals to square root of x squared plus 1. This becomes k plus 2y. I'm going to say 2y plus k squared equals x squared plus 1. Actually, I think it's x squared minus 1. Never mind. It's x squared. It's x squared plus 1. That's fine. X squared plus 1. So this will give us x squared minus. Sorry, never mind. I'm gonna just go on and rearrange all of this. This becomes minus, right? If we move this s squared to the left hand side, positive becomes minus. And then just the whole thing equals to 1, right? So this is what I call the standard form. So now what we're going to do is we're going to match the equation with the basic conic equations, right? And I have showed you, right? These are the conic equation, basic conic equations. So what does it mean? What does that mean for our problem, right? In our problem, right, because x term and the y term both are squared, and have opposite signs. Right? And if you examine our hyperbola equation, right, x squared, y squared, and it's the opposite sign of each other. Therefore, this level curve looks like a hyperbola. Right? Right? You can apply the same technique that I just showed you to many type of problem, right? Your result might look like ellipse, might look like a circle, it might look like a parabola, but it has to be one of these 4 types. So right? So this kind of question requires a little bit of thinking, requires a little bit of math, but I hope this solving process would help you to, first of all, identify, and then how to solve these questions really quickly without sort of think about, oh, how do I derive this? How do I, what's the definition of level curves, right? I skip all of that step, broke it down to the simple steps that you can take, and then you can just, go ahead and do it. So I hope you learned something from my video. I thank you very much for watching, and remember, the steps are always much more important than the numbers themselves, because you can apply them to many problems. And with that said, I will see you in the next video.